So let's look at all the end behavior for this particular function. Now, I have f of x equals 4x cubed minus x squared plus 3x minus 2 over 3x cubed plus 13x. Now, I'm noticing here that I have x cubed as my biggest in the denominator. That's the highest order in the polynomial in the denominator. So what I'm going to do is, first of all, I'm going to take a look at the limit to the right. So I'm going to take a look at the limit. When I said to the right, I meant as we go to infinity. As x goes to positive infinity of 4x cubed minus x squared plus 3x minus 2 divided by 3x cubed plus 13x. And I'm going to multiply both the numerator and the denominator by 1 over x cubed, 1 over x cubed. Now when I do that, I end up with a limit as x goes to infinity of 4x cubed over x cubed minus x squared over x cubed plus 3x over, whoops, this is supposed to be cubed, sorry, x cubed minus 2 over x cubed. That's all the numerator. The denominator becomes 3x cubed over x cubed plus 13x over x cubed. Now I'm going to start looking at canceling. The x cubes goes away. It'll go away there and leave me just 1x. It'll go away there and leave me with x squared in the denominator, and nothing cancels there. This will cancel out, and that'll cancel, leave me with x squared in the denominator. So now what I have is a limit as x goes to infinity of 4 minus 1 over x squared plus 3 over, I'm sorry, that's not an x squared, that's an x. There we go. 3 over x squared minus 2 over x cubed, that's my numerator. And then I have 3 plus 13 over x squared. Now, in the limit, this will go to 0, this will go to 0, this will go to 0, and this will go to 0. So what I'm left with is simply 4 over 3. Now, what you're probably taught back in pre-calculus or college algebra is that as x gets big, if the numerator and the denominator have the same power, polynomial, then what ends up happening is everything else essentially cancels out, and you end up with nothing but their coefficients, which is exactly what we had here. And that's actually a true statement. However, I'm not going to let you do that. The reason that's true is because of the limit. When we take this limit properly, that's what gives us a statement back in pre-calc that simply take a look at the leading coefficients. If the power or the degree of the numerator is the same as the degree of the denominator, and that's what you're going to give you your horizontal asymptote. So here, the horizontal asymptote as x goes to infinity is in fact 4/3. And although I'm not going to actually work it all out, I think you can probably see, let me grab green here. If I simply change this to negative infinity, all of this work is going to be the same thing. I'm going to change this to negative infinity. So now I'm taking a look at the horizontal asymptote, if there is one, as I move to the left. All of this work is going to be the same. This would be negative infinity, and I still end up with 4/3. So if I produce a graph of this, asymptotically, I will get 4/3 in both directions.